Hello class, today is the 13th of April, and as I had mentioned at the end of last class, today's video we're going to go through is we're going to go through A and B of the exploratory exercise 3. Now we're going to pass by C, and this video should be pretty short, all things considered, simply because, well, we're only going to be going through part A and part B, and they're actually pretty quick. A here says, hey, look at the graph of y equals f of x for the function f of x equals x squared that we did in exploratory challenge 1 again. Would we see a difference in the graph of y equals g of x if we used -2 as our scale factor instead of 2? So back to this first example. If instead of it being f of 2x, what if we did f of -2x? Well, we could graph it, or we could do it in a table as well. So that's what I feel like we're going to do right now first. We're going to do this in a table, especially since we already know what our table is going to look like for f of x, and we know what it would look like for f of 2x, so we can then compare that to what f of -2x would look like. So we'll do the same, -3, -2, -1, 0, 1, 2, 3 that we had before. And for f of x, we're going to have 9, 4, 1, 0, 1, 4, 9, just like we had before. And then for f of 2x, if we remember, everything was what we had over here times 4. So we had 36, 16, 4, 0, 4, 16, and 36. So let's see if these values are going to change any bit, or how they are going to change if we use -2 instead of 2. Well, -3, if I were to plug in -3 here, it would be -2 times a -3. That gives me a +6. So negative times a negative gives me a positive. And then +6 squared, oh, well, I mean, that gives me 36. Okay, -2 times -2 gives me +4. +4 squared gives me, oh, well, that's 16. Oh, just like what we had over here. -1 times -2 gives me +2. +2 squared gives me, oh, well, that's 4. 0 times -2 is, well, 0, and 0 squared is, well, 0. And you'll notice, hey, everything that we have here is actually the exact same as f of 2x. Now we need to think to ourselves, well, why? Why is that the thing? Well, because when it comes to squaring things, it doesn't matter if your answer is going to be if your input is positive or negative. When you square something, you can never get a negative answer. You're always going to get a positive answer. So even if we negate this, it's not going to change because we're still squaring it. The question is, well, that's if we're squaring things. What if I was doing a function where I wasn't squaring stuff? Would doing that negative change anything? In some cases, it might. In this specific scenario, no change to our graph here. There's no change to our graph because multiplying it by a negative doesn't change the fact that we're squaring it. And when we square a negative number, we're going to get that positive answer. Take a look at B. B says a reflection over the y-axis is going to take the graph of y equals f of x for the same function that we've been using today. Well, not today, yesterday. F of x equals x squared back to itself. So it's going to reflect over the y-axis. Such a transformation, we call that a reflection symmetry. It's reflecting over that y-axis. What's the equation for the graph of the reflection symmetry of the graph of y equals f of x? Well, we can do a rough little sketch here. Of our graph of y equals f of x is equal to x squared. Remember, it's going to look a little bit something like this. And again, this is just a rough sketch. It's not 100% accurate because obviously I haven't drawn any lines for where any of my values are, but this should be completely fine as just a sketch of what our f of x equals x squared is going to look like. Now what we're going to do is, as it says, we're going to reflect it over the y-axis. So any points on the right side of our y-axis are going to go over to the left, and these on our left are going to go on over to the right. So this point right here would be 1, 1. In order to get to the y-axis, I'm going to move 1 space. Let's actually do this in blue. And to move over to the y-axis, I'm going to move 1 space. So I'm going to need to move 1 space past the y-axis to end up here at negative 1, 1. Well, hopefully you can see something here. Let's check that out with this one as well. This point is 2, 4. So that means our distance from the y-axis is going to be 2 units. So continuing, I need to go past the y-axis another 2 units. Wow, do you look at that? I'm going to land here at negative 2, 4. So for this specific function, the reflection symmetry of this graph, y equals f of x, is going to become y equals f of x. Or you might think that it will become y equals f of x. Because here's the thing. It's going to look exactly like y equals f of x. It's going to look exactly like f of x equals x squared. But as we learned in part A, we learned that, hey, if I take my input and multiply it by a negative number, for example, when I multiplied my input by negative 2 instead of positive 2, there wasn't any change. Though technically, there is a quote-unquote slight change. It's just that we can't see what that change is on our x squared. If we were to use a different graph, such as maybe a linear equation, we'd be able to see how this would change things. But it is actually going to reflect everything. So this 36 is actually that one. This 16 is actually going to be that one. This 4 is that 4. 0 is still 0. This 4 is actually that 4. This 4 is actually, this 16 is actually this 16. And this 36 is actually going to be this 36. Everything technically flipped. It's just that, well, both sides were the exact same, so it didn't make any sort of an actual difference. So instead of this being y equals f of x, technically going to be y is equal to f of negative x. The thing is that, well, it just still looks the same for f of x is equal to x squared. But this negative x, similar to how before when we took our entire function and made it negative, how it reflected it over the x-axis, if I take my input and make it negative, it's going to reflect over my y-axis. Though again, just want to note that reflecting this function over the y-axis literally doesn't change how it looks in the slightest. Just know to reflect, or another way to say this, reflection symmetry is achieved by multiplying the input by -1, or better said, to reflect over the y-axis, multiply the input by -1. Because negative x is just -1x. So we're taking x and multiplying it by -1. So if I want to reflect over this y-axis, it's going to take my input here and multiply it by -1. 2, multiply that by -1 gives me, -2. 1, my input, multiply that by -1. I'm getting -1. We can even do this in the reverse as well. If I started with my -1 point, to get to that y-axis, it's going to take 1. So I need to go 1 past it, and I'm going to end up at 1, 1. My input, -1, multiplied by -1 gives me, 1. So it's going to work out so that in order to reflect over this y-axis, I'm just going to multiply my input by -1. So with that, that's the end of this video. What your responsibility for today is you guys are going to finish the problem set from this lesson. So just the problem set from this lesson, that's all you got to do for the rest of today's class. In any case, I will see you all tomorrow. Everybody have yourselves a great rest of your day.